Okay, so we're definitely getting the idea of what exponential functions are, what they look like, how they increase with that constant ratio. So let's just work on writing exponential functions. In example 3, we have a table of values. Here's our x's, here's our f of x, which are our y values. And the question is, what is the written form of the function represented by the table? So just as a reminder, we saw this in our vocab video. An exponential function has the form f of x equals a times b raised to the x power. So that a is the initial amount, and that b is the constant ratio. So we're going to take a look at our table of values and see if we can identify the a and the b values, and then we can just write our function. It's kind of like y equals mx plus b. Can you find the m and the b, the slope and the y-intercept? Now we're looking for the a and the b. This b has a different meaning. Can we find the initial amount and the constant ratio? Okay, so looking at our table of values, we're going to start right there. This is the initial amount. So the initial amount happens when x is equal to 0. So if you look at a table of values, you would find where x is equal to 0. That f of x or y value is the initial amount. So that tells us that our a is equal to 4. It's also the y-intercept. If we were to graph this, that's where we would cross the y-axis. So that's our initial amount. Now we have to find the constant ratio. So what we do is we pay attention to our range values here. We want to take note of how they are increasing. If this is an exponential function, they should be increasing by a constant ratio. Are we multiplying by the same number to get to the next number? And there's actually a pretty decent mathematical way to find the constant ratio. So if you start with the second y value, so I'm going to start with the 12, and I'm going to divide it by the term before it. So 12 divided by 4 is 3. So 3 is the ratio to get from this ordered pair to this ordered pair. Now, and we can do this as long as our x's are increasing by 1, which they all are. So now let's check. Let's take the third number. We're going to divide it by the second number, so 36 divided by 12. What we notice is that is also a 3. We're going to continue this through the table to see if we get that 3 every time. 108 divided by 36 is also 3. 324 divided by 108, guess what? That's also 3. So what that 3 means is if we go through the table forwards, 4 times 3 is 12. 12 times 3 is 36. 36 times 3 is 108. 108 times 3 is 324. That 3 is the constant ratio. So that means that our b value is 3. So now we can write our equation. F of x equals, we've got our initial amount of 4, so 4 times, we've got our constant ratio of 3, and we raise that to the x power. You also could write it this way, f of x equals 4 with parentheses times 3 to the x power. Both of these would be acceptable. Okay, so can we write an exponential function from a graph? So just a reminder, exponential functions have the same form. F of x equals a times b to the x. So can we find the initial amount and the constant ratio? Initial amount is when x equals 0. So we can see that x equals 0 right here. So our initial amount, a, is 128. Now let's take a look at the ordered pairs they highlighted. Here, x is a 0, x is 1, x is 2. This point right here, x is a 3, x is a 4, x is a 5. So our x's are all increasing by 1. So we can check to see if we have a constant ratio by dividing. Let's take the second y value of 64 and divide it by the y value before. You know, actually, I think it's helpful if we write these ordered pairs out. So we have 0, 128. We have 164, 2, 32, 3, 16, 4, 8, and then I think we have one more, 5 is a 4. So let's check that division. 64 divided by 128. Well, it doesn't divide by 128 because it's too big, but that does reduce to a 1/2. Now let's check 32 and divide it by 64. Oh, that also is 1/2. 16 divided by 32. 1/2. 8 divided by 16. 1/2. And 4 divided by 8. 1/2. So we have a constant ratio of 1/2. So our b value is 1/2. So we can come back, write our function, f of x equals, our initial amount a is 128. Now if your b value is a fraction, I do prefer that in parentheses, so times 1/2 raised to the x power. One thing I want to point out with this, and then we'll be done with this one. Do you notice how this curve, as we move along the x-axis, this one is actually going down? The last one we saw, it was going up like this, but this one is going down. So the reason that is decreasing is because our constant ratio is less than 1. Every time you move along, we're taking half of the previous number. So 28 times a half is 64. 64 times a half is 32. 32 times a half is 16. So if your b value is less than 1, then your y values will decrease. And this is what this exponential function looks like.